Let's go into some real problems today. So why is normalization bad and we should probably stop using it? First of all, there is the minus problem, which some people may be heard of. Minus clicks are subtracted before normalization, so they have a bigger impact on judges who click less and almost no impact for judges who click a lot. This can result in a situation where judges actually agree, but they can get opposite order. This can be fixed, but we need to specify a mistake weight for that. Second one, the maximum problem. Scores are normalized by a single value, the maximum score for each judge, which means that they are very sensitive to this maximum value. If you mess up your maximum score, you effectively mess up all the other scores. This is a big problem, and it's exactly what happened in the previous video about normalization. This can be fixed by more clever computation though. This relates to the third point, which is that it makes your score dependent on each player. But that just doesn't make sense in principle. Freestyle is just an independent thing. Why should its rating be partly based on rating of other players? And it creates weird conflicts, like if you disqualify a player, should you put him in the spreadsheet? Because his scores can actually influence the results. This is related to the fourth point, that it makes scores incomparable between contests or even rounds of the same contest. This prevents us from doing some very interesting things with the results, but more importantly, it makes it harder for players to improve, because it's hard to guess if you actually got better. And if you design a freestyle, you want to make sure that it is better than your last freestyle, and you cannot really tell that from normalized score. You cannot estimate how much your freestyle actually scores. This is often very frustrating, because if you get a bad score, you have no idea why, and there's no way to actually know why. It could even be your best freestyle, but you will never know, because normalization just hides this information. This is related to the fifth point, which is that it makes the system confusing and hard to understand for everybody, especially for outsiders. But even worse, it doesn't stop people from interpreting those values. I heard someone cheering that he got 48 points for the first time, which is meaningless because this value is dependent on other players and on the contest. People misunderstand how it works, interpret these values in a wrong way, and they get wrong information about that. But this applies even to judges and organizers. There is a common phrase between judges that it doesn't matter how you click as long as you are consistent, because of the normalization. But that's not actually true, that's not true at all. It matters a lot how you click. There's also that heat map in the spreadsheet that is used to compare scores from different judges. But it's actually wrong and misleading, because it compares values that mean different things and that were normalized relative to different target. But people will still extract some information from this that is incorrect. All this could be kinda acceptable, except it doesn't solve the real problem. It's a workaround. Real problem is specifying how to click and what is the weight of each positive click and each negative click on the final score. Normalization only hides this problem and makes it harder to solve. But even as a workaround, it doesn't really work well, because for ideal case, it does more harm than good. If judges actually click the same way, normalization propagates their error from each score to all the other scores. This effect is even worse with the maximum problem, but it's present even if we fix that. Eighth, it makes it hard to find problems with the system itself. Minus problem and maximum problem are easy fix problems that are super obvious, but because our results get so obfuscated by this computation, we didn't notice it for 20 years. And it also makes the results unverifiable, but this is more because of the clicking is not specified well. Ninth point, final number is meaningless. It's aggregated as an average of values that each mean a different thing. Average only makes sense if it is aggregated from values with the same meaning. Think average distance, average salary, average age, average height. Which brings me to the final point, that it's conceptually wrong. is an average from whatever each judge clicks minus number of mistakes divided by maximum of those times 60. Our normalization is just an arbitrary computation on data that has a different meaning. It just scales the scores on the same level. In other words, it implicitly assumes that whatever judge clicks minus number of mistakes divided by maximum of those numbers is a multiple of whatever some other judge clicks minus and so on, which is not true. You can actually see this if you graph these scores. Even if we got rid of minus problem and maximum problem, we would still be left with an assumption that number of positive clicks of one judge is some multiple of number of positive clicks from the other judge, which is not true at all, because judges can count different things. So relationships between their scores can be different. It can be addition, it can be linear combination, it can be anything. Their scores cannot be different only by constant or scaling factor. They will differ for each player. Just for example, if one judge clicks hooks and the other one clicks only hops, how can we say that the first one is a multiple of the second one? And what is an average of those values? What does it mean? What's an average of number of hops and number of hooks? It doesn't make sense. And even if we just simplified it and just said it's an average of judge scores and judge score is just something and it's up to judge, this method is still unjustified because there's a multiple methods that we could use. So how to solve this? Well, I propose instead of designing some crazy and complicated arbitrary computation, let's just finally solve the real problem and let's describe how we should click and how these clicks should be counted in the final score. So that's all for today. Thank you. My first videos were just kind of abstract rambling, so I decided I will take a different approach today and get into some actual problems. So I hope you like it, even it was kind of controversial, and see you next time.